Hello everyone. So let's start solving today's problem. Fraction pairs with sum 1. So in this problem we have been given a numerator list and a denominator list, and our task is to find which fraction has the sum equals to 1. So this is a just slight variation of the problem. Count the pair of a given sum. So this is, you can consider it a prerequisite. So if you have solved this problem, you will get it, you will get the solution very easily. Okay, otherwise you will have to go visit that problem once. So in this problem, what we have to do is we have been given the numerator array and denominator array. So let's first write it down. So 1, 2, 2, 8. And the denominator array consists of 2, 4, 6, and 12, I guess. So if you look closely, this 1 and 2 can be represented as 1 divided by 2. This 2 by 4 can be represented as 2 by 4. And this 2 by 4, if we cancel it out, we will have 1 by 2. And when we take the sum of this 1 by 2 and this 1 by 2, we get the result as 1. Okay. So this can be a possible answer, right? This 1 by 2 comma 2 by 4 is one possible answer that makes the sum equals to 1. So we increment the count since we have to count the pairs. So we have incremented a count 1. Again, we check this 2 by 6 or this 2 by 6. So this is 1 by 3. And for 8 by 12, we have 2 divided by 3, right? So when we add 1 by 3 and 2 by 3, we will get 1 as result, right? So again, the sum is equal to 1. So we again increment our count. So in the end, our count is 2. Okay. And we return this count. So that's what the output says. So let's try implementing this approach. So what we'll be doing is the intuition of this problem is we are finding out the GCD of the number since not all the numbers are in its simplest form, right? For example, consider the example 2 by 4. So in order to add it with 1 by 2, we have to first reduce it into its simplest form, that is 1 by 2, right? So in mathematics, we simply cancel it out, which means like this, right? We reduce this by, we divide it simply denominator and numerator by 2 and we get 1 by 2. But here, what we'll be doing is finding out the GCD, the greatest common divisor of both of this number, and then dividing it by both of them. So if you didn't get it, let's take another example like 12 and 24. So the GCD of 12 and 24 is 12 itself, right? The greatest common number that can divide both these numbers is 12. Okay, so what we'll do in order to reduce it into its simplest form, we will divide 12 to both of them. So we will have 1 divided by 2, right? So first we'll be finding out the GCD, then we'll be dividing the numerator and denominator by GCD. Okay, then we'll be using a map since we have to, if you look at the topic text, we have been suggested to use a map. So we can use an unordered map in order to keep track of the other element. For example, if we have 1 by 2, we can search for the other pair, which makes the sum as 1, right? So how can we get the other pair in order to make the sum equals to 1? So what we'll do, the other pair could be 1 minus 1 by 2, right? So the other pair is 1 by 2. So we check in the map if 1 by 2 exists. So for example, if you were given 3 by 4, so the other pair would have been 1 minus 3 by 4, that is 1 by 4. So we would have checked, looked up for the 1 by 4 in the map. And if it existed, that means that both of these pair can make a sum up to 1, right? And we increment the count. Okay. So now let's consider the case of this 1, 1, 1, 1. So numerator has all the ones and denominator has these ones, right? So the if you look closely, the then you will get that the sum can be this, this one, this one, this one, and this one. So forget about it. Forget about it. We will be adding the frequency. All I'm saying is we'll be adding the frequency in our count because if you remember the uh, pair sum question, you will know that in the pair sum problem, what we were supposed to do was we were given an array, suppose like this, 1 1 1 1, and the we were given the sum 2. So what were the possible pair that could sum up to 2? It were these two, then these two, then these two, again these two, and these two, and these two ones, right? So the sum were, so the total number of count that could make the sum up to 2 were 6, right? So that's the reason that we are adding the frequency instead of the number itself. Okay, so I have implemented the same idea. So I have used a nested unordered map because we are storing the new fractions, right? So we cannot store fraction in any data structure. So thus I have used this int for numerator, this int for denominator, and this is the count. And initially count is 0, and we iterate over the this 4, and we keep finding out the GCD and then dividing it to the numerator and denominator. And we check if the rest, if the other element exists in the map, then we simply sum its frequency. All right, and we increment the number. Okay, so if you submit, this code works fine. Right. Thank you.